Good morning. Welcome to today's networking discussion. I'm Professor Kennard. We're here to go through Chapter 1 of the text, which is Introduction to Networking. We're going to be talking about what the purpose of a network is for, mainly the different types of devices, as well as addressing the types of networks that you have and their applications. We use different terms in networking that you'll see throughout the course. So if you hear network services, you might also hear the term application. The purpose is a network is there to share different types of what we call resources. So a resource could be something as simple as a file or a printer. It could be a website. It could be an entire ERP system. So that we'll use the term resource as well as application. Under the hood, you might hear us use the term service, or even farther under the surface, we might say protocol. There are different types of applications that you'll see discussed in the text, client server and peer-to-peer being the two main types, but you'll see others mentioned as well. So with client server, as you'll see in the listing, that's the dominant type of networks that we see today in terms of applications. As you see in the list, web, email, others that we'll get throughout the course. But you can see those are really the main types of applications that we find today. They're again referred to as client server. So in the slide here, you can see the internet, which some people confuse for being the web, but it's not the same thing. So the internet being the infrastructure, the series of connections of networks, the user is requesting a web page via a web browser. That's the software running on their machine known as the client, and then you have web server software running on the web server. We'll get more into that in the future chapters. Other examples, email. So we could say email is the application. Under the hood, there are a set of one or more protocols that provide that service to the application. So here you can see examples such as SMTP, POP3. Lots of alphabet soup this semester. We'll get into all of them. File print, a little bit more basic, but that too represents a network application. If I want to make files available, devices such as printers available, then you need to make those resources available somehow on the network. That could be done in a fairly simple environment known as peer-to-peer, which is to say each system has something that it's sharing, a particular resource, and then the other machines are functioning as clients that are requesting the services on that particular machine. What you don't see in that slide is any mention of a particular server. So it's a little bit simpler of a setup. Over the long haul, it can get a little bit more complicated. So you can see in the slide there, it's simple for small networks. It's inexpensive because you don't need complicated server operating systems, but you can see the problems are it doesn't scale well. It doesn't grow as your needs change. And it's also not as secure. So client servers, you can see here being a more dominant type of what you might call an administrative model. So all of the security, lots of the services might be isolated on one or maybe several machines, and then the clients are simply requesting those services from those one or more servers that you have. So NAS, a network operating system, that would be something like servers you can see on the slide, or Linux is a popular server operating system as well. Now we will be getting into the different components that you need for the network. So the application technically is one component, but as we get into more hardware types of things, you'll see some devices mentioned in the slide there, or at least in the diagram, you can see a switch mentioned as a particular device. We'll see others such as hubs, routers, wireless access points, and more. That diagram is also referring to a particular topology, sort of the design of the network. That physical topology, as you can see, is what's known as a star topology, sometimes called hub and spoke. This slide shows a combination of topologies. So you have three separate devices that are connecting maybe three separate classrooms, three separate buildings, three separate offices, and then they are all connected together on what's known as a bus topology, a single line connecting them all together. Larger types of networks, you might need other types of devices. So here you can see in addition to switches, which are representing individual networks, all of those networks are then connected by one or more routers. Stepping back even farther now, so if we need to connect multiple networks together via ISPs or providers, you can see now there is what's known as a WAN link. So they're also mentioning you could have what's known as a metropolitan area network, which is typically within one particular city, municipal area, or wide area networks, which can really span the entire globe, but you need a provider to give you those kinds of connections. We'll spend a lot of time this semester discussing the OSI model. So it's broken up into 7 layers, as you can see here with the color coding. The top 3 layers are really all about the application itself. So you'll see presentation and session are mentioned there, but really most of the time we spend talking about the application itself. And again, the examples are the application being web or email or FTP. Under the hood, each application is made up of one or more protocols or services that are allowing that application to function. Transport layer, different protocols, different job. It's not the application, it's how are we delivering the application. The network layer, how are we getting that data from the application from one place to another using protocols and addressing. Data link and physical layer are more about connectivity, using the network card and getting that NIC connected to a particular device on your LAN. We'll spend a lot of time this semester discussing the interaction of these 7 layers of the OSI model. If you have a good understanding of the OSI model, you'll do very, very well in the rest of your networking courses. We'll go through the interaction of the layers, and each device has a particular job to do. Each device is functioning at a particular layer of the OSI model. So at the end of this chapter, you'll understand each layer has a job. Each layer has something that's doing that job. And then each layer has either maybe a piece of hardware or software, or sometimes both, that's getting that accomplished. So that wraps up chapter 1. We will discuss this and have a brief quiz at our next class.